let's talk about more exponential functions. So we talked about yesterday growth and decay, right? So in real life, something like population growth, and something with decay would be something that we're counting how many years ago that it died, or half-life of atoms. Lots of different things in science. I don't think we're going to do the heads up activity because I know, maybe we'll do it tomorrow. Because I really want to get through this exploration right now. In the last class period, they had a hard time getting through it. So we'll come back to this tomorrow. Okay, so, and you guys out of 3 periods today are the only ones that were like, aw, everybody else pretending like they didn't like heads up, and then they had a really fun time playing it. So I'll let you guys do it tomorrow. Okay, students will be able to graph exponential functions by identifying transformations. So yesterday we graphed a couple different exponential functions, right, with different bases. Today we're going to concentrate on one base, and we're going to apply transformations to it. Okay? All right. So let's talk about growth and decay. So yesterday when we had a base of 2, it was growing, just like this, right? But then we found that when we had a base that was a fraction, it was decaying, it was falling. Okay? So what we didn't talk about, so this is why we say when B is my base, you're going to see that over and over again. So when B is greater than 1, for instance, 2 or 3 or 4 or 10, our base is growing. If it's a 10, how does our base grow? Can somebody explain that to me? What would a base of 10 as opposed to a base of 2 look like graphically? It would be very steep, right? It's going to shoot up really, really quick. It would have actually the same, this first reference point would be the same, 0, 1, right? On all of our graphs yesterday, they were all at 0, 1. Right? But then my next reference point, the one where I go over 1, would shoot up, actually, it would shoot up the base, 1b. You see that? So if the base is 2, so if I had a graph like this that was y equals 10 to the x, my second reference point would be 1 comma 10. See, I said 1 comma b is my second reference point. Let me erase it. It's my second. So my first reference point was 0, 1. My second reference point is 1 comma b. So what would my reference point be if I had 3 to the x? What would my second reference point be? 1 comma 3. Okay, so we're going to be using these kinds of things today to make transformations. All right, so I'm going to go ahead and erase this. And go back and start talking about this. Okay, so when we have a fraction, we know that it's falling or decay. We also talked yesterday about if I had a fraction like this, that wouldn't be decay. Did we explain why that wouldn't be decay? Because it's greater than 1, right? 5/4 is actually bigger than 1. So that wouldn't be decay. That would still be growth. So just because you see a fraction bar doesn't mean that it's decay. You got to make sure that it is indeed between 0 and 1. All right, so today I want to talk about what would happen if our base was negative. So I'm going to start off with a -1 for a base. Can somebody tell me why that's impossible? Not because it's negative. Okay, let's debunk Sarah's theory. What if it was 1 to the x? It's not greater than 1. If it was 1, what's 1 to the 0? What's 1 to the 2? What's 1 to the 5? Can we use 1? No, 1 doesn't work, right? 1 just gives us this constant line. So I can't use -1 either. It's not going to work. Let's try -2. We like that common base of 2. right? We know it. We understand it. We know that its first reference point is at 0, 1, and its second reference point is at 1, 2. It's a nice one for us to play with. So let's look at negative 2 to the x. So let's talk about negative 2. If it was to the power of 0, what would it be? If I was to make x 0, what's y going to be? What's negative 2 to the 0 power, guys? 1. What's negative 2 to the first power? What's 1 negative 2? I should hear a universal response right now, and I don't hear one. What is 1 negative 2? Thank you. Negative 2. What is 2 negative 2's multiplied by themselves? What's negative 2 3 times itself? Negative 8. Doesn't make any sense, right? So we started here, and then we went here, and then here, and then here, and then what do you think we're going to do? Back up? Is that a function? No. It's not a function. Why do you get quieter as you're saying the complete sentence? You're right. It doesn't pass the vertical line test. Okay, so if all of our spectrums of numbers, B can be greater than 1, can B be a million? Yeah, B can be greater than 1. Anything bigger than 1, then our exponential function is growing. B can't be 1 because then it would just be what? A constant line. B can be a fraction or between 0 and 1, and then it's falling, right? But it can never be a negative number. Now, I'm just going to say this now in case we don't get it to it completely in your homework. This and this are two completely different things. You see what I'm saying? What's 2 to the 0 on this one? Negative. No. Yes, you're right, negative 1, I'm sorry. I don't even want to, let's graph it with a different color. Let's graph it with green. Let's make this green. So if it was 2 to 0, we wouldn't get 1, we would get negative 1. Right? What if I put 1 here? What would I get? Negative 2. What if I put 3 here? Negative 8. Sorry, negative 4. Right? So it's going to be doing this. Right? And the next one would be negative 8. Okay, so if it's inside the parenthesis, the exponent is affecting it, and we can't have a negative. But you can have a negative on the outside of it. Okay, this is the kind of thing we're going to be doing today. We're going to be looking at how transformations occur, but much more. Okay, so let's talk about a few of these features. I'm not going to do all of them today. I'm just going to concentrate on the first 3. So this is our friend, 2 to the x, right? This is all we're going to be dealing with today is the base of 2. This is our parent graph. If we were dealing with a base of 3, it would be a whole other parent graph. It would have the same shape, only it would be a steeper one, right? Okay, so there's a couple things I want to note. This one, of course, is growth. Because, why is it growth? Because B is greater than 1. Let's be specific on this, right? Our base is greater than 1, that's why it's growth. Our reference point, I'm going to say reference points. What's my first reference point on this one? You guys did it all day long yesterday, right? 0, 1 was our first reference point. If I set x equal to 0, 2 to the 0 equals 1. My first reference point is 0, 1. My second reference point is when I go over 1, right? I already plugged in 0 or substituted in 0. What's the next one I always substitute in? 1. when I put in 1, substituting 1, what do I get? I get 2. Or 1 comma b. The same as the base, right? That second reference point that I'm getting is the same as the base. So my second one is 2 to the 1 gives me 2. My second reference point was 1, 2. All right, my asymptote. Now this may be falling. It may look like it's touching that line, but is it? No, you guys learned that before. This, I shouldn't be drawing it as a solid line. I should be drawing it as a dashed line. This is my asymptote. There's another, not asymptote. We can't call it an asymptote. I'm going to call it the reference axis. And that's not anything that's in the book. I made it up last period. Okay? Sounds official to me too. I like it. Okay. So, I think this is going to work. My reference axis is where my exponent was 0. Okay? So when my exponent was 0, I got 1. Isn't that always, wasn't that our reference point from the very beginning? That's our very first reference point. So I'm going to call this the reference axis. And you're going to see why in a little bit. All right. The last thing I want to talk about is just naming this asymptote. What is this asymptote? What if it was here? What would we call it? 8. What would we call that? What would that asymptote be? It's just 8. 8. Y equals 8. Good. So if it was there, if it was y equals 8, then what is it here? Y equals 0. Good. So my asymptote here is y equals 0. So those are the things that I want you to think about as you go through these. So my first one, I'm going to go ahead and, let's see, let's take a picture of this. How do I want to do this? All right, let's look at this one. So what's my first, this one's also growth, right? What's my reference point on this one? What's 3 to the 0, guys? 1. That's my first reference point. 0, 1. What's my second reference point? If I put in 1, what am I going to get? Didn't I say 1 comma b? What is my base? 3. So I go over 1 and I go up 3. So if I put in 3 to the 1, I get 3. 1 comma 3. There's my second reference point. What's my asymptote? Y equals 0. It's right here. All right. I don't think that one was necessary. Let's go back now, because this one was going to be on your homework, and I don't think we're going to get there. Your homework was going to be a base of 3, and the in-class activity is a base of 2. I don't think we're going to get to the homework. I think we're just going to go slow on this one. All right. So let's take this example here. I think what I'm going to do, I'm going to do this one on a different graph. I want to make it big. I'm going to model exactly what I want you to do with computers. All right? So let's start here. Let's get myself a graph. And let's start with this one in the middle. Let's start with 2 to the x. We know this one by heart now, right? This one, my first reference point is at 0, 1. My second reference point is at 1, 2. Good. What if I go in the negative direction? Negative 1. It's only going to go up half. Because y, because 2 to the negative 1 is equal to a half. Remember the symmetry that we had with that? 0 equals 1. If I put in 1, I get 2. If I put in negative 1, I get a half. So if I put 2, I get 4. If I put negative 2, what am I going to get? 1/4. If I put 3, I'm going to get what? Not 9. 2 cubed is 8. So what's negative 3 going to be? 1/8. Remember that, how we talked about that yesterday? Okay, good. So remember that. All right. So this is my parent graph for today. That's my parent graph. Take this, send it to the back, and then group. Group that right there. Okay, so the first one we're going to work with is, call it g of x. G of x equals 2 to the x plus 3. Let's see what happens. Okay, so here's my table. What do your tables look like? It has an x. Looks like this. All right, let's see what happens. What's the magic number we put in on all the rest of them? 0. So let's try 0. So if I put 0 in, then I get 2 to the 0 plus 3. What is 2 to the 0? 1. That's what we got before, right? But this time we're going to add 3 to it, which makes 4. So I'm going to go 0, 1, 2, 3, 4. Let's put in 1. Let's see what happens. 2 to the 1 plus 3. 2 to the 1 is 2 plus 3 equals 5. I put in 1, I get 5. 1, 2, 3, 4, 5. Let's put in negative 1. 2 to the negative 1 plus 3. 2 to the negative 1 is a half, but I'm going to add 3, which equals 3.5. Can I say it like that? Isn't that easier than changing them both to fractions? And we don't need to do that. If I have 3 and I add a half on a graph, I just know I have to go over 1 and up 1, 2, 3, and a half. Do you see a trend happening? If I do negative 2, can I argue without doing any math right now that if I put in negative 2, I'm also going to go up 1, 2, 3, and a quarter? And if I went over without doing any math, if I went over again, I'd go up 1, 2, 3, and a 8. And this one would be a 16th. And this one would be a 32nd. That's without doing any math. No table. Just understanding the relationship between the numbers. Okay? So what's this one going to be if I go over here to 2? It's going to be up 1, 2, 3, and how many more up? Okay, let's do this. Do you guys see that you've got an asymptote right here on my original one? So where's my asymptote on my new one? We got to change our asymptote color. Y equals 3. My asymptote's at y equals 3. So if I were to pretend right now that I don't have, all I did was take this and I went up 3. Right? So normally if I were to put in 2, what would I get? 4. Right? So if I put in 2 from here, I'm going to get 4. 1, 2, 3, 4. Well, I should get 4. There we go. 1 second. I need to change the color of this. So here is 1, 2, 1, 2, 3, 4. This one is also up 4. but it's not 4 from here. It's 4 plus how many? 3. So shouldn't it be at 7? So over to 1, 2, 3, 4, 5, 6, 7. Same graph, shifted up 3. Let me give away the big surprise before we even do any more. Oh, I want you guys to discover it. So difficult not to just tell you. I want you to figure it out for yourself. Okay, so I just did 2 to the x plus 3 for you. I'm going to give you your activity. I'm going to give you about 5 minutes to discover the second transformation. That was the first transformation. Would we call this a vertical or a horizontal transformation? It's a vertical transformation. It's going up 3. What do you think if this says negative 3? What do you think it's going to do? It's going to go down 3, right? So let's find our horizontal translation and see what happens with it. So I'm going to pass that out right now. Okay, so let's try another one. Let's try 2 to the x minus 3. And I think, again, I'm going to just start my own page here. And I'm going to write our parent graph, which we had in green, right? Was the last one in green? Yes. All right, so my f of x equals a base of 2 to the x is up 1, 0, 1, and 1, 2, like this. Put this to the back. Graph all that together. Okay, so let's go on Desmos. I'm going to go out of here. Go to desmos.com calculator. Desmos.com calculator. Let me turn the lights off. Thank you. All right, so the first one we're going to put in is f of x equals 2 and then a base, the a to the b right here, to the x. So that's my red line. Let's change it and make it this one. This one. Green. So it matches my other one. Done. All right. Now I'm going to try this same thing. So I'm going to control copy. Can you guys just listen to me for a second? If you like what you're doing. Okay. So on this one, it said I'm going to put parentheses around it. That's how I do it on Desmos. So is it x plus 3? All right, let's look what happened. I'm going to take a screenshot of this one. That's not what happened to yours. So it's shifted over by 3. Let's do it on here. So I still have the same asymptote. My asymptote on here is y equals 0. Only all of my points on this one are shifted to the left 3. Right? So this point's going to be shifted over 3. 1, 2, 3. This point's going to be shifted over 3. 1, 2, 3. This point's going to be shifted over 1, 2, 3. Now this is how I would do it. You could do it however you want. I heard Michelle talk about how she likes to do the table first. So she likes to have the table and discover the graph. Right? Isn't that what you said? I like to have the graph and check it with a table. So I know this whole entire graph is going to shift over 3. Let's see if I'm right. So which point would you like to test first? 1, 2. I don't want to test 1 because I didn't even really have a point there. You want to test 0? You want to test 0. Okay, let's test 0. So if I put in 0, I'm going to get 2 to the 0 plus 2 to the 0 plus 3, which is 2 cubed, which is 8. So if I put in 0, I get 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm not quite sure, Sarah, if I'm right, because I might have just been sloppy with my graph, but it looks pretty close. Let's try another number. What number would you try next? You want to go over 2 this way? We want to go over -2, because that would get us closer over here. Okay, let's try -2. So if I put in -2, I'm going to just go -1. Because you guys I want to just show you the progression, okay? So -1 would give me 2 to the -1 plus 3, which is 2 to the 2, which is 4. -1, 1, 2, 3, 4. I'm almost right on that one, right? Now let's try the -2. So 2 to the -2 plus 3 is going to give me 2 to the 1, which is 2. You see how they're falling like this? See how it's just shifted over? So -2 gives me 2. I'm right on that one. Let's try -3 and see what happens. 2 to the -3 plus 3 equals 2 to the 0. Bingo. This is my magic reference point. I just got 2 to the 0. Right? That's that magic reference point. So when I go over 3, 1, 2, 3 on the x-axis, I go up how many? 1. It's right there. Okay, so my reference point is actually in the same exact spot. It's just shifted over 3. So let's talk about what all this means. Here's our magic formula, guys. You're going to see lots of letters that you're familiar with, okay? What do you think B stands for? Base. What do you notice up there? There's an H, there's a K. What does K normally stand for? Vertical transformation. What does the H do? Horizontal transformations. What does A do? Scale factor. Also, if there's a -A, we're going to see a reflection, right? Okay, so let's apply some here real quick. I've got what, like 3 minutes? All right, so I'm going to do this one. How about f of x equals, we're working with 2s, 2 to the x minus 2 plus 4. What does 4 do to me? That's going to make my, you guys please don't pack up. What does the 4 do? Moves it up 4. 1, 2, 3, 4. It doesn't move my graph, it moves my asymptote. Right? Then what does this -2 do? It shifts it over, right? That's how, so we're going to go over. It's just like we've been doing forever. And this is what I'm talking about with my reference axis. So if I do my math correctly, I should, pretending right here, now, if I pretend like we're here, right? So what's my first reference point going to be? 0, 1. What's my second reference point going to be? Over 1, up 2. Let's check. And if I went over this way, I'm going to go up a half. Let's check and see if it works. If I plug in, what would you guys say my reference point would be right here? That's my first one. So that's where x equals 2. Let's check. Right here, where x equals 2. Let's substitute in 2. So I have 2 to the 2 minus 2 plus 4. Remember how I told you? As soon as I get an exponent of 0, then that's my first reference point. Plus 4. What is 2 to the 0? 1 plus 4 is how much? 5. Let's see. Let's double check. So if I go over 2, I should have to go up 5. 1, 2, 3, 4, 5. Bingo.
Bingo.
So you could graph these without doing any work. Or you could do all the work and then graph it. You need to do both. Okay? My preference would be, all I want to see on these is 3 points to check it. If you want to use transformations to find all of these, go ahead. But you just need 3 different points to prove it. If you want to do the work and do the table first and then graph it, be my guest. That works too. If you want to use Desmos and do a little bit of both and kind of guide yourself, because when you get to these guys, you're going to have to discover something else. When you get, that's going to be my A, so you guys said that that's going to make it the scale factor change. And what do you think this one's going to do? Go down. Okay, well, I don't know. I guess we'll see tonight, right? We'll talk about it tomorrow? Okay. The only thing, guys, the only thing I want you filling out over here is this. The asymptote and the reference point. You have 2 reference points. Have a good day.